Okay, this is what we went over in class. Um, and we used the weight force, the equation here, and also I gave these notes for you guys to have as a resource. If you see units of kilograms, for instance, like you do right there, then you would put M equals and you're given. If you see meters per second squared, you would then use A equals whatever that quantity is. And if you see newtons, then we know that it's force. I also gave you the other two equations that you would use if you're asked to find G. Then you use this equation. If you're asked to find M, then you use that equation. Okay, now the example this I went over was the first problem, which is right here in front of you. And just like I just finished mentioning, okay, we need to use the guess method here. And this is the only way I'll accept your work, if you use the guess method. Okay, what is given in this problem is right here. What is this a value of? You have to write M equals. It's very important that you write the M, because that's the whole purpose of doing the guess method, is by writing down what quantities are given, the quantities that are unknown, and finding the equations based on the quantities that are given and unknown. If you don't write this, it defeats the whole purpose. And I won't give you credit for the problem. Okay? And since we are talking about something being pulled down or its weight, it's asking what the scale reading is. And what do we mean by scale? How much, what measures your weight? Okay? So if we're measuring weight, we're going to use G. G is given as, on an average, G for the Earth equals 9.81. Now remember, that's just the average acceleration due to Earth's gravity. Now, this 9.81 varies depending on how high, how close you are to the center of the Earth. Okay, if you're closer, it's a stronger pull, and if you're further, it's not as strong. So this is just the average. And the reason why I mention this will become clear on problem 2. Okay, which will ask you for G at a specific location. Okay. Now, what the question's asking for is what the U is. Unknown. What is unknown here? The weight. The weight, which is force. Okay. Our everyday meaning of weight is in pounds. In physics, we use newtons. We use force. Okay. Pounds is a force. In physics, we use weight, and we represent it by force with a subscript W that represents weight. And what's the equation that relates M, G, and F? The whole reason why we write it in the first place. What's the equation? Is that's given right there, no problem. Okay. Let's just write the equation. All right, now what we're looking for is already isolated to the left, so we don't have to change the equation around. Now from here, you're home free. All you have to do is write every symbol unless it has a number that's, unless it's represented by a number. We have force is not represented by a number because that's what we're looking for. Okay, we have an M, which is right here. If you didn't write the M, you wouldn't even know what 4.0, what that even means, which is why it's so important that you write it down. Okay, and we have, excuse me, I'm going to do this a little bit differently. We got 4.0 for M. For G, we have 9.81. Keeping in mind that the number with the fewest digits is this one, which is 2. Remember, zeros to the right only count when there's a decimal. Zeros to the left never count, even if there is a decimal. And I'm going to put the units out here. And that was our substitution step. And here's our solution. Just write down your solution. And if you multiply those, you get 39.24. Now the units are kilograms meters per second. You've seen that before up here. But instead of writing all that, we just write newtons. And the reason why I mentioned significant digits, because our answer needs to be with the same number of significant digits as the number with our fewest significant digits. Here's our number with the fewest significant digits. How many does it have? 2. So our answer needs to be the 2 significant digits. Here's how I represent what's going on between these two numbers. To 2 significant figures, our force will equal, do I need to round up that 9? No. 39 newtons. Box in your answer. Now, what I want you to keep in mind is that as soon as you write your unknown right here, notice how everything else follows right below. And that's what I want to see. It lines up nicely. Okay? All these line up nicely. That's what I want to see. I have a lot of papers to grade, and this helps me get through it quickly. Okay, now as you go through these problems, please keep in mind that, for instance, number 2, although we have a value, it's asking for g. We have a value for g, and it's right here. But remember, I said this is the average value of g around the planet. It varies depending on how close to the center of the planet you are. In other words, your elevation. Okay? Now, this one's asking what's the gravitational field at that specific location. So what you're looking for is little g, okay? Your u for this problem is little g, okay? And we have the equation right here to solve it, okay? Let's say number 4, it gives you a maximum amount of force a bag can withhold before it rips, okay? So what you're looking for is force as a result of these, and then you need to compare it to this one to determine whether or not it's going to break. Okay. Now this is the back side of the paper. Okay. You have to finish these problems as well. Okay. Now notice the similarities between this equation right here and this equation right here. Okay. It's the same thing. Remember, g is an acceleration. However, it's more specific to the acceleration due to gravity here on Earth. When we're not dealing with gravity and weight, and most likely in these problems that don't have g in it, we're talking about something accelerating to the right or to the left. Okay? Then we just use regular a. All right, so for this example again, for every one of our problems, we're using the guess method. Okay? And our first value given to us is right here. We have a force of 13.2 newtons. Sometimes that's not given to you explicitly the way it is here. Just by looking at this, you should be able to tell that we're talking about a force. So our first given is there. Now, again, explicitly given, okay, to the left. Okay. So our acceleration is 0.44 meters per second squared, keeping in mind that zeros to the left never count, even if there is a decimal. Okay, so we only have our number with the fewest significant digits is this one, and it has 2. Keep that in mind as for when we write the answer down. Okay, now our unknown is straightforward. What is the mass? It's straightforward. All you have to do is write m. Now keep in mind, guys, I give 20% if you do that, 20% just for doing this part, 20% for writing the equation, and 20% just for writing the solution. Now, see, we already have an equation, but if we need to solve for m, those cancel, and then you divide by a, you need to get the m on top, which is why we did this step right here. Then you divide by a to both sides, and you get m equals f over a. However, keep in mind this equation was already solved on the first page right here. Right here, actually. M equals f over a. Just g is the same thing as a, however, more specific to Earth's gravity. So there's our equation. Now I'm going to write the substitution with certain units just to make something just a little bit more clear than it would be otherwise. What I mean is I'm going to write force, but instead of writing newtons, I'm going to write the expanded version of the units, which is right here. Okay. So it's kilograms, which is units per mass, times acceleration, which is meters per second squared. Okay. And our acceleration value is 0.44 with meters per second squared. The reason why I wrote it this way is because it's much more clear to see how meters per second squared cancels out, and you left alone with the units for mass. Okay. And after you plug in, make sure you line up your M nicely. Okay, just like that. Line them up nicely. And our solution is exactly 30 kilometers. Now remember here, the number with our fewest digits is this one right here, and it only has 2. Okay, so this has to be written with 2. Zeros to the right only count when there's a decimal. So we have to put a decimal. Now our 0 counts, or you can write it as 3.0 times 10 to the 1, or times 10. Okay. Box in your answer, and there you have it. Now, number 5, let's see. Make sure on number 4, one of these you're not going to use. Okay? Let's see, what else would you might need to know? Okay, we're going to use 5 as extra credit. Okay, this one is extra credit. And the reason being is because we're not given A. You have to use the values here. You're looking for mass, you have force, but you're not given an acceleration. How can you find the acceleration? Using what you have. Okay. That's the hint for number 5. All right, get it done, guys. And if you were absent yesterday, which was Tuesday, November 8th, then this is due on Monday for you guys.